A very good day to you all, and a warm welcome to free webinar on methods for evaluation of extension of time in construction projects, a collaborative effort between Structural Design Institute, more commonly known as SDI, and our esteemed partner, Civil and Structural Engineering Consortium Private Limited. If this is your first time with us, SDI is an educational institution that has a lot in store for you. We specialize in engineering, covering areas such as design, construction, and software training. What sets us apart is our close affiliation with Civil and Structural Engineering Consortium, a name synonymous with excellence in the field, having worked on several iconic projects in Sri Lanka. At SDI, we are committed to the continuous professional development of engineers. So we offer CPD courses and events for those pursuing chartership or looking to enhance their skills. You can see a few of our upcoming and ongoing projects here. We are focused on structural analysis and design, architectural modeling, and even some courses focused on specialist topics. What sets us apart from other similar organizations is our exceptional faculty, as our educators are all practicing engineers with extensive real-world experience, some of whom are even renowned in academia. We also offer a set of publications, including tall building guidelines for Sri Lanka and construction specifications for tall buildings in Sri Lanka, as shown on the screen, with more to come. These books encapsulate our team's wealth of experience, diving deep into design and construction specifics. Today's webinar is the fourth in our series for the year, Methods for Evaluation for Extension of Time in Construction Projects, focuses on project management in the construction industry, a critical area that underpins the success of any engineering or infrastructure project. This session will be highly informative, offering valuable insights into managing construction projects. It is a great opportunity for both aspiring and practicing engineers to deepen their understanding of real-world project management practices and challenges. So before we begin today's webinar, I'd like to go over a few housekeeping points to help ensure a smooth and successful session. First, please note that a certificate of participation will be awarded to all the attendees who complete the attendance form. The link to this form can be found in the description of the YouTube live video. And we will also be sharing it in the YouTube live chat. Please note that this attendance form is not open yet. I repeat, the form is currently not open and will only be accessible once we announce it during the webinar. When the time comes, we will post a message in the live chat indicating that the form is open. So please keep an eye on the live chat for that notification. Once the form is open, it will remain available for only 20 minutes. So please make sure to fill out within that time if you wish to receive your certificate. If you experience any issues while trying to submit the form, kindly take a screenshot of the problem and send it to us via email or WhatsApp. Please note that we will not be able to answer phone calls during the session, so messaging is preferred for any assistance. Now, I would like to introduce our resource person. It is with great pleasure that I introduce our distinguished speaker for today's webinar, Engineer Athula Samarasinghe. Engineer Samarasinghe is the Executive Director of Civil and Structural Engineering Consortium, where he has been instrumental in overseeing and managing numerous landmark projects across Sri Lanka, including some of the country's most iconic high-rise buildings. His leadership and strategic vision have been central to the successful execution of these major developments. He is a chartered engineer and holds a Bachelor of Science in Civil Engineering, a Master's of Business Administration from the University of Sri Lanka, and is a member of the Institution of Engineers Sri Lanka. With years of experience hands-on industry experience, Engineer Samarasinghe brings a rare blend of deep technical expertise and practical project management knowledge. He is a highly regarded professional in the field, not only for his contributions to engineering practice, but also for his commitment to capacity building. He regularly conducts courses on project management, sharing his valuable insights and knowledge with aspiring engineers and industry professionals. We are truly honored to have you with us, Engineer Athula Samarasinghe, and we look forward to an insightful and thought-provoking session. Now, I may hand over the session to the resource person. Over to you, Engineer.
Good afternoon to you all. First, I would like to welcome all of you for the webinar conducted by the SDI. Methods for evaluation of extension of time in construction projects. Okay, first, for moving to the methods of evaluation of the extension of time, we'll just go through some of the basic definition or details highlighted within this topic. EOT, extension of time, it is a formal request for entitlement under the construction contracts that allow the contractor additional time to complete the projects beyond the original agreed completion date without being penalized due to delay that are outside the contractor's control. We have a contract agreement at the very beginning in any construction project. So there might be situations where we have to extend the time period, and that is reasonable for the contractor, or it's not under his control. So in that case, we are offering an extension of time. Okay. Extension of time basically happen in relation with the delays. So basically in the project, we are identifying 3 types of delays caused by different parties. Understanding the nature of delays is more important in the construction industry. Delays fall in 3 categories: those caused by the contractors, delays prompted by the client or his consultant, and external delays which not expected and uncontrollable. What are the causes effect for this extension of times? Client variations. I am directly moving to the topic. I expect you all know the background of the construction project, and I am not moving with the backgrounds because we have limited time. I have focused on the topics, so I am directly moving to our topics. So please excuse me if you cannot, or if you are not familiar with some terms. And the delays in approvals of permits. Normally we have to get the approvals of permits from some authorities before moving the projects. In some cases, we get delays. Late delivery of information or materials by the client, that is under the client's obligation. Unforeseen site conditions, example, hidden utilities or contaminated soils. There are other lot of reasons we can find at the site. Extreme weather conditions and force major events. That is normally we call act of God. Next, we'll see why we need this EOT. The extension of time is important for project parties, for the contractor and the client, for the following reasons. Protects contractors from penalties. Normally, EOT allows contractor to avoid liquidated damages when delays are caused by factors beyond their control, such as bad weather, design changes, or delayed approvals. Maintains fairness. That ensures equitable treatment when delays are not the contractor's fault, preserving good working relationships. In order to move forward with the projects, actually, all the parties or the stakeholders need to have a good relationship while moving the project. Next one, enables accurate planning. EOT helps in realigning project schedules, resources, and costs when unexpected events impact the original plan. Supports claims and compensation. It forms the basis for cost claims. Avoids disputes. The properly documented and agreed EOT minimizes the risk of legal disputes by clearly establishing the reason and impacts of the deal. So all parties understand cause of delays or providing extension of time and the reasons. Maintains contractual clarity. It keeps the contract terms by officially updating the completion date, which is crucial for tracking project performance. So under the EOT, what are the benefits or importance provided for the projects? From the contractor's point of view, they can claim for several costs under EOT claims, including site office, site overheads, head office overheads, etc. According to the contract terms. Next, time-related cost for extension of times. Preliminary cost normally we have at the very beginning in the contracts, but for the extended times we don't have such permits. So that giving direction how the contractor can claim and the clients should pay for their time periods and their performance. Next, finance and insurance related costs. Of course, when you extend the time, we have to extend our insurance, bonds, and other finances related documentation works. We have to continue. That incur additional cost. So these kind of things we can plan with this properly evaluated extended time periods. In the construction industry, you know, we cannot avoid delays, and it is very difficult to run any project without delay events, and consequently, we will find the EOTs. And there's a process for us to follow while we are expecting a EOT claims. First, we have to notify the delay, or contract has to submit the delay events. Next, assessment of cause and impact of the delay. So what is the cause of delay? All parties has to agree, and we have to assess the impact because of that event. Then contract has to submit their EOT claims with the supporting document. Once it's submitted, the engineering party or the client representatives, they have to evaluate and approve, or they are not agreeing with the contract or their contractor's claim. Once the EOT granted, so we have originally work program project, we have to reschedule with this new time schedule. So that is the basic process we have to follow with this EOT application. In construction projects, normally this delays we can classify based on the responsibility, impacts, and compensability of the case. So first one, based on the responsibility. Who is responsible for the delay? Number one, that is excusable delays. Excusable delays, that is granted to the contractor, that delay caused by the event beyond the contractor's scope is not liable for this delay event. So it is excusable to have an extension of time. With this excusable delays, sometimes we will not be getting any cost sometimes. That is, depend on the contractual provisions of the contract. Next one, non-excusable delays caused by the contractor's own fault. The contractor's fault, according to contract, we are not giving any extension of time. So he is not entitled for any EOT or compensation for the delays, but he will get liquidated damages. Next one is the compensable delays. That is caused by the client and or their agents. With that case, the contractor is entitled for the EOT, and definitely contractor can get compensation for the cost benefit. For example, I can say late issue of drawings, site access restrictions, client initiated variations, like that events, we can highlight it under the compensable delays. Next item is the concurrent delays. Normally, in the projects, it's not as you think, it is not smooth. There are cases we can find multiple delays occurring at the same time, caused by both parties, contractor and the client. So in that case, the entitlement depends on the contractors according to the contract, and sometimes the EOT may be granted without cost compensation in such cases. based on the impact. The delays we can categorize that is impact critically to the project completion. Critical delays and non-critical delays. Critical delays affect the project critical path and overall project completion. Non-critical delays occur for the non-critical activities and does not affect project completion dates. So I hope I could say again. So I think you know what are the critical activities and what are the non-critical activities means. The project driving activities, which means without delay, the activity we call the critical activities. So if we have some buffer to delay some certain time periods, we call them as non-critical activities. That is all the things we are getting from our construction program. Next one, the delays we are classifying based on the timing and the knowledge. Foreseen delays, that is no win delays. Once we enter to the site of the project, we can anticipate there might be delays due to some reasons. So in that case, mostly we can mitigate the delays and can take actions to avoid such delays. And there are some events we can see unforeseen delays, so that cannot be predicted. And in such cases, we can get the EOD claims. I have extracted this figure from one research paper. I'm sorry, I didn't cite it. Mobile whom I have taken. Anyway, we'll go through that. You can see the causes for the delays. Some yes highlighted, like contractor-related factors, client-related factors, consultant-related factors, material-related factors, equipment, labor, general equipment conditions. Those are the mainly we are finding at the site causes for the delay. And with that causes, we are getting the effects like cost overrun, time overrun, and litigation and abandonment the project. Let's now move to our today topic. Once we enter the project, we have to analyze our delays and we have to provide some details or some reports to the project stakeholders. So we can analyze our delays under two methods or two techniques. First one is the retrospective delay analysis method, and the second one is the prospective delay analysis. Retrospective delay analysis refer to the process of analyzing delays after the project or a portion of it has been completed, using historical data and actual progress records to understand what caused the delays, when they occurred, and who was responsible. Which means we are analyzing the delay once the things have happened. So this type of methods we call retrospective delay analysis method. I can highlight some key features of the retrospective delay analysis are that based on the actual data, because we are getting the past or the historical data, so we have the actual data. we use the real progress data and the site reports, correspondence, and logs. Focuses on what already happened and not focus on the predictions. So we have the real-time data. So we are dealing with the actual figures. And this method we are performing after the facts, conducted after delay has occurred, and often during claim preparation and dispute resolution stages. And also we are identifying the responsibility and entitled. Who is the responsible for this delay, and is it entitled? Is there any entitlement for the EOT? And can use various methods. So in the retrospective delay analysis method, we are using normally, I will come to these points later. We come with the as planned versus as built method, and the collapse as built, and the time impact analysis. These are the analysis methods we are moving with this retrospective delay analysis methods. In that situations, we are gathering with the gather reports and compare actual progress with the planned milestone, identify delayed activities and critical path effects, and analyze delay causes and categorize them, and determine the delay duration and the responsibility, document findings in the delay episode, the claim report. So this is the steps we are following under the retrospective delay analysis method. These are the time we are using this retrospective analysis. The project is completed or substantially progress. We are dealing with historical data and need to resolve disputes or evaluate claims. Client or contractor want to understand what went wrong. So with this analysis, we can get or we can understand where we found or where we went wrong. Like this, we are normally saying lesson learned. Also, we have some limitations while you are using this retrospective methods. We are relying heavily on the quality of project records. So if we don't have any records in perfect manner, we cannot use this method. So that's why normally every time we are instructing for all the project stakeholders to keep records in proper manner. And can be this method can be subjective if data is missing or poorly maintained. If we don't have the data, sometimes we are assuming and providing some input. So that is that may be subjective. Often more complex and time-consuming than prospective method. So we'll come next to the prospective method. Before that, this is complex and time-consuming because we have to go the historic data, all the records, inspection reports, meeting minutes, document transmittals, everything we have to check and validate when you are analyzing this EOT claims. So that is a limitation for this project, for this method. Okay, next one is the prospective delay analysis. Prospective delay analysis is a forward-looking. So previously we were looking at the backward. Now we are moving to the forward-looking method used to evaluate the potential impact of a delay before or as it happens, based on the current schedule and the project status at that time. In this method, actually, we will be having a construction program which has been agreed or approved by all parties, contractor, client, or the engineers party. So we have a project now, a project plan, construction program. So we are using that as a baseline. And when the event is happening or a delay event is happening, we are using this program and dealing with the project completion dates based on our knowledge. So we are focusing the future. Prospective delay analysis method, we have these key features. Forecast future delays. It predicts how a delay might affect the project completion using a planned progress and scheduled data. Planned progress means our baseline. And used during ongoing projects. So we are conducting before the project completion, often when a delay event is identified or anticipated. We are anticipating the project completion. Also, this method supports extension of time request early. So while we are moving with the project, we can analyze and grant the EOT to the contractor, so without any doubt between the parties. And relies on updated project schedule. So we are mostly relying on the updated intermediate. We are updating the progress for the project program. We are relying on this update and moving forward with that. So the prospective delay analysis method, we have identified two methods. There are some other methods, but I have taken these two. Those methods we are calling impacted as planned. Delay events are added into the original baseline schedule to see the effects on completion and the time. Second one, the time impact analysis. So all these 5 methods I am talking later. So for the introduction part, I have taken and explained to you. In this method, we have the advantages like helps make timely decision during project execution. While the project execution, we can take the decisions and assist in proactive management of delays rather than waiting till the last moment. We can proactively deal with our delays and encourages early resolution of claims. So at the early stages, we can discuss and come to an agreement, or we can resolve the many problems with this method. Of course, this method also have limitations. So we are dealing based on the assumptions and forecast. While we are developing our construction programs, we are getting the activities and we are making the relationships according to our assumptions. So this will move forward like this. But in some cases, that in the future, that will not come in the same way. So that reflection might not be accurate. Of course, less accurate if the baseline schedule is poorly maintained or unrealistic. So if you have not properly evaluated our construction program, or it has been done without having much attention, so we are focusing on, we are predicting some unrealistic data. Maybe dispute later if actual events differ significantly from the forecast. So as I explained, the events might be differ in the future. So in that case, some can argue, okay, we have analyzed the EOT based on this sequence, but that has been changed, so we cannot accept like that. disputes might be coming. Okay. Now, with today's topic, these are the delay analysis methods. Normally, we are practiced at the site. These are standard methods. Normally, these methods we can find in the industry, and these methods are being recognized by Society of Construction Law, SCL, generally known. So we are practicing these methods. No one can say this is the perfect method. There are methods, so we cannot say this is the method we should follow by just looking at our theoretical knowledge. So these methods to be selected based on our contract documents or the agreed methods highlighted in the contract. Okay, the number one, first method I have taken the as planned versus as built. Okay, this is one method we can take to evaluate the EOP claims. In this method, normally we are approaching compares the planned schedule to the actual schedule. Planned schedule means the baseline, the one we have agreed at the very beginning, and the actual means the updated program while the progress is ongoing. And we are using for the suitable global claims based on cumulative delay impacts. And this is advantages, simple, low cost, use actual data. And this is disadvantages, ignores changes to the critical path during the project. So when we are explaining, you will understand these things. And this is based straightforward comparison when critical path changes are minimal. Okay, in this method, the key components we are finding as planned schedule. As planned schedule means, for this method only I will explain these terms. For the next method, I am not going to explain because we have limited time. So you can remember. As planned schedule is the baseline schedule that is developed at the start of the project. It outlines the sequence of construction activities, their durations, start and finish dates, and their interdependence, which is relationships. This schedule reflects how the contractor intends to execute the project from start to completion. So that is the planned schedule. As built schedule is the this is actual progress of the project, including the actual start and finish dates for each activity, the duration of delays, and the reasons for those delays. This schedule is created after or during the construction process to track deviations from the original plan. And how we are going to compare or analyze this method is we are compare with this as planned schedule with the as built schedule. From there, we are identify which activities are being delayed, and these activities the critical path. If it is affecting the critical path, we are directly getting the project delays, or for the if it is affecting to the non-critical activities, sometimes we may get delays to the completion of the project, or sometimes we will not. The total impact of these delays on the overall project duration, yeah. Okay. As plan schedule, I explained some list of activities, planned start this day, duration of each activities, dependencies between activities, and the critical path activities. We are focusing on these things. Okay. Okay, this is a graphical view for you to understand clearly about the description. At the upper portion, we have the as planned, our schedule. So 1, 2, 3, 4 means our activities. It has been sequenced there, and the lower portion is the as built, how we have moved forward in the project. So activity 1, you can see one part, the activity 1 has delayed, and activity 2, it has been complete early from our planned duration, and activity 3, we have started early, but that also has been completed late, and the activity 4, it has been delayed start, and the overall delay we can find from the as built to the project. Okay, with this method, with the as plan and the as built, we are comparing, and we are getting the overall delay to the project. In the meantime, we can check individual activities where we have delay. So this is the method we are. This is the simple method we are practicing at the sites to identify the extension of time. Okay, this is a small example for you to understand this method. There's a project, Sophie Mall project. The project has planned to complete by 31st December. The baseline schedule includes critical activities such as excavation, foundation work, steel framing, and roofing. And in our plan schedule, excavation we have to finish by 15, start by 1st January. Foundation start from 16th and finish by 1st January. So these are the dates, roofing, and the final handover is on 31st December. And according to the as-built schedule, we can find excavation we have given as per schedule, and the foundation delayed due to unforeseen ground condition, and it has been finished by 20th February or 20 days later from the plan, and the steel frame delayed, and that has been started on 25th and finished on March 25th. And there we find 25 days later. Roofing, we have finished on 10th April. They are 25 days later, and the final handover January 31st. So the final completion date has been jumped to 3rd of January. With that, two conditions. So according to our comparison, what has been, what we can see, excavation, there's no delay. Foundation work, we have 20 days delay. And based on, because of that, steel framing, we have 28 days delay, so 24 days delay, and roofing work delay 25 days, and those are accumulated because of the foundation work delay. From the analysis, as the schedule shows that the foundation work was delayed by 20 days due to unforeseen ground conditions. In that case, we can say those are excusable delays. Unforeseen conditions, we are giving the extension of time because contractor is not liable to that situations. And moving with that, we are completing the project by 31st January, and then overall we have 31 days extension of time with this analysis. Okay, that's a simple example for you to understand. So this is a simple method we have in our delay analysis. Main advantage with this method, it is simple, and that clarify all these situations where the delays occur, and this is effective for retrospective analysis, which means we can analyze this after the project completion. We have the actual data, and the disadvantages. This method we can only use with this retrospective analysis, and this is not dynamic, which means while the project is going on, we cannot do this exercise, and also we cannot use this method for complex projects. Okay, next one is the impacted as plan. We have a plan project. So we are analyzing how that delay is being impacted the plan work. So our approach is a delay event to the as planned schedule to simulate their impact prospectively, which means we are identifying the delay event, and delay event we are taking in separate manner, and the time duration and the other relationships we are enter into the plan program and analyzing while the project is moving forward. And this one is more commonly used by the contractors because it is dynamic, and the main advantage clear we can identify cause and effect for each delay, and this is mostly accepted method. And the disadvantages of producers theoretical research, because I explained you in the prospective analysis method, we are mostly moving with the theoretical to our assumptions base. And this is best used for the early stage delay assessment and when limited progress data is available. Because this is when the project's early stages, so we don't have any method or we don't have any future data, so we can move forward with impacted as planned. When we can use this method before the project start, I explained. If the schedule has not been properly updated during execution or inadequate, of course we don't have real-time data, so we have to move forward with our original program. And after change or delay has occurred, and so we can predict how the owner of the contractor or how this delay affected to the final project outcomes. So these are the steps we have to follow while we are implementing this method. Start with your as planned schedule, baseline schedule. It is typically your baseline schedule, and identify the critical path and of the project finish date. So in that case, we have to identify the project critical path. I think you know know how to identify the critical parties. And the next thing is that we have to identify the delay and its duration. So we have to separately take this delay and insert an activity. We have to insert to the project like an activity to the schedule, and that represents delay event, and it has to be linked appropriately to the project program. And then we have to run the project. Normally, we are using in this project Webinar in acceptable by the industry for this kind of activities. So we have to update the program, and from there we can find out what is the effect of that delay event. If it is affecting to the critical path, the project completion date will be moved forward. From there, we can say because of this delay event, project completion affect this much of time. So in advance, we can analyze. Okay, this is a small graphical mode for you to understand. Upper portion, we have the plan baseline schedule. You can see there are 4 activities highlighted in green color. And at the bottom portion or lower portion, we have green color ones. Sorry, blue color ones are our plan activities. In between, we have red color activity, that is the delay happened in between this project. So we have entered, we are now calling as some fragment, delay fragment we have insert, and we have run the project. From there, we can identify the time has been lagged, and that time gaps we are calling, or we are giving as an extension of time. Okay. Third method, we are calling as collapse as built. This approach actually removes delay event from the as built schedule to analyze what if scenario. So I will explain this. And we use this to evaluate delays retrospectively. We are moving backward. And the advantage is highlights party-specific delay impact. So, which party is responsible for the delay impact, we can identify with this method. And the disadvantage is subjective and data intensive may introduce bias. So, if we don't have actual data, so if the data has been manipulated, that may be give some bias on the analysis. And this is best for the projects with linear sequence or smaller scope. So this also we are not recommending to use in the complex projects. Okay, on this method also we have as built schedule I have explained. And the identification of delay events. I explained you, we have to identify the delay event, and we have to highlight that event. So here we have taken some reasons such as client instructions, design changes, site conditions, weather, or contractor related issues. So whoever is responsible, we are taking that delay item, then delay fragment, and analyzing with them. So removing delay events. So in this method, the specialty is we are using the as-built schedule. So once the project is completed, we are taking the actual scenario, and you know, for the delay events, there are 2 parties responsible. One is the client, side, including the consultant, and the other one is contractor's delay. So what we are doing, we are taking one's delay. Let's say client delay, we are taking out from project and running the project and identify the delay. So I will explain more. And these are the steps on this collapse as-built analysis method. First, we have to prepare the as-built schedule. So normally we have to do it regularly, and once the project is complete, we have to do this as-built schedule. And identify the delay event, whether it's excusable, non-excusable, or compensable, whatever the delays we have to identify. And these events we have to remove from our as-built schedule. So here it has been described. Once the delay events are identified, they are removed from the as-built schedule to create the collapse schedule. So we don't have the actual program now. We have collapsing. Collapsing, we have taken one part out and scheduled the project. The purpose of this is to determine when the project have been finished, had those delay events not occurred. So we are now analyzing if that delay was not occurred, what will be the project completion. So if there is any advance of the project once this has been done, so as-built completion and the new scheduled date, the gap we can consider as the delay was due to that delay event. And we have to compare, I explained this actually, compare a collapse as-built versus as-built. The collapse as-built is compared to the original as-built schedule. The difference between the two indicates the impact of the delay events on the project completion date. And from there, we have to determine what is responsible and whether it's compensable or not. We have to decide. Okay. I think with this graphical mode, you can clearly understand. At the very top, we have the as-planned schedule. Activities are A, B, C, D, E. And as-built calculation schedule we have. Activity A has delayed because of the owner's fault. Owner was delayed. And activity B doesn't have anything. C, D doesn't have anything affect some delays. And the activity E, contractor was delayed. It has been highlighted here. So that is the as-built calculation. So in the third program, we have removed the owner caused delay from the program, and we have analyzed the program. So what has happened to now? The as-built calculation schedule showed some date, and with this collapse as-built schedule, it has been more advanced. So that gap we are calling the delay caused by the owner. So in that case, contractor is not responsible, and we have to grant that extension of time to the contractor. So contractor caused delays actually he has to bear. So we don't normally want to analyze that. The advantages of this as-built collapse as-built method is clear causes for delay. So cause for the delay we can clearly identify, and extension we can directly grant. From there we can identify who are the responsibility owners. And this is suitable for complex projects because we are taking fragments for the delay events and analyzing. So this is good for the complex project. And ideal for retrospective claims. So we are dealing with as-built data. So this is good for later on claims. And the disadvantage is subject to interpretation. We are dealing with the as-built data. So if the things has been not properly documented, we are facing some problems. And this method requires detailed project reports and documentation to accurately assess the impact of each delay. So if we don't have proper reports, we cannot perform this method. And the last one is, or the final one, the window analysis, time impact analysis. There's small difference between time impact analysis and window analysis, but commonly both are generally same. So many of the situations we are talking in a single topic. With this method, the approach is insert delay event at specific snapshots of the project schedule to evaluate their individual impacts. This is dynamic analysis for major delay events. And the major advantage is objective and systematic evaluate delay timing precisely. And the disadvantage is this is highly consumed labor intensive and depend on the frequency and the accuracy of the data. And this is good for projects, major delay events needing precise quantifications, which means this is the most advanced or the recommended method and precise method when we are analyzing the delay events. In this method, the key components baseline schedule, the window period. So how we are dealing with this method, we are dividing into small intervals of the project. We call it as a windows. Into time segments, we are dividing this, usually defined by, or we are segmenting into monthly or quarterly periods. With periods only we are analyzing this method. This delay events that occurred in each window. So window means that time segment are identified and their impact on the project schedule is evaluated. Part by part, we are, or window by window, we are evaluating the delay events. And from there, we are taking all windows we are analyzing and cumulative impact we are calculating for the project completion or delay analysis. Steps in window analysis: prepare the baseline schedule. The first step is to develop baseline schedule. This schedule, all the details are included, and the second step, divide the project into windows. The project schedule is divided into small time periods, monthly or quarterly period. These windows are selected based on project milestone. So there are decisions we have to take how we are going to divide this period in the program. So that's a project decision has to be taken. Then we have to update the schedule after each window. So first we have to update the schedule in the first window. Next, evaluate the second window, and likewise we have to evaluate each window, and finally we have to get the cumulative delay impact from each window. Okay, there's a small example for you to understand this. So, in our office complex project, the foundation, structural work, and finishing work, it has been divided into 3 phases. Project has baseline completion on 31st December. During the project, delays occur due to design changes, bad weather, and resource shortages. The contractor uses a monthly window analysis. So, window, the period is 1 month, and they are evaluating with that window. Step 1, you need to have baseline. That will be that shows completion of 31st December, and divide into window. We have to divide each month, January to December, and we have to identify delay events. There are 3 delay events, I think, that we mentioned in the example. So January, March, and June. So we have to get this delay fragment and insert those things in the respective windows. And from there, we have to get the updated schedule. January has been post delay of 15 days, and March 10 days delay, and June contractors material shortage, there are 20 days delays, but that is not excusable or no extension of time. The excusable time, January and March, altogether 15 plus 10, 25 days. Extension we have to grant for the project. And a Windows analysis method, the main advantages are this dynamic and ongoing analysis. And this is granular details mean we are dealing with small windows, so we can detail it and analyze very accurately. And effective for large projects because we are in small segments and comparing to the large whole project. So that's benefit for the evaluation. This is much accurate because dynamic and we can pay more attention and there's much less chance to get errors, and therefore this is the recommended method. And the disadvantages, this resource intensive because with this each side time period we need people to analyze and keep the records to deal with, and require detailed documents, and complex projects we can deal with this method, and it's difficult to implement retroactively because we are moving proactively with this method. Okay, this is a summary of all the explained methods. You can see there are 5 methods I have explained. There are some other methods, but they are not commonly used in the industry. And the availability of information and the time of analysis, it has been either after the project completion or then project ongoing. And their capabilities and their advantages and the resources requirement are highlighted and summarized here for your references. Actually, this is within 1 hour. It's very difficult anyone to explain, but it's a webinar. So we are normally thinking that some sort of knowledge you are having, and also this is a good exposure. Now you know after you prepare the program, so there are other things also you have. Though it is not common mostly in Sri Lanka, but other countries they are mostly using this kind of methods. So they are not just giving EOP or the other compensation without this kind of analysis. So with this knowledge, I think you can read much more and documents, get experts' knowledge for your development of or improvement of that knowledge. So thanks SDI and the team for organizing this event, and thanks everyone for joining for this webinar. Yeah, thank you.
Thank you, Engineer Athula Samarasinghe, for delivering a highly informative and insightful session on the evaluation of extension of time in construction projects. Your detailed discussion on delay analysis methods, contractual considerations, and practical applications provided immense value to all the participants, I believe. And it was indeed a thought-provoking and engaging session that we had today. We are very grateful for the opportunity. And that opportunity we got to collaborate with you in the continued journey toward building a knowledge-based society. And I think now it is time for the Q&A session. Participants, if you have any questions, you can direct your questions to the live chat. Before we start the Q&A session, I would like to remind you again that the Google form for attendance is available in the YouTube description and is now open. Let me repeat, the Google form is now open. You all can fill out the attendance form if you wish to register and for the certificates. Please note that the form will only be open for 20 minutes. So if you wish to receive the certificate, please make sure to submit your response within that designated time. If you experience any issues while accessing the form, please take a screenshot of both the issue and the YouTube webinar page and send it to us via WhatsApp or email. So now I think we can start the Q&A session. Participants, if you have any questions, please drop them in the YouTube chat box, the live chat. We will direct your message to the resource person and get you the answers for those questions. We will give you 1 to 2 minutes to drop in the questions to the live chat. One question: how do project managers balance cost implication when approving time extensions?
Balancing cost implication when implementing extension of time means actually we need to have some provisions. Expecting there are delays can be happen from the client or the engineer side, because for the delays happening from the contractor side, we don't need to provide any cost. There's no cost implication. With that, we have to deal with that available provision. We have to deal for the extension of time. The best thing in the contract consultants or the client side to avoid delay events, as I explained before, if they don't have a budget for such events. Otherwise, there will be disputes, and we have to end up with the court or dispute boards to resolve this kind of situations. So there is no any specific method to avoid this cost implication unless we are taking precautions to avoid such delays.
I think we do not have any more questions, as our resource person descriptively and elaboratively discussed everything related to the topic. So thank you everyone for joining. First, thank you, Engineer Athula, for answering all the questions from the audience and clarifying the doubts. And it was a very engaging session, I must say. And all the participants, thank you for joining our webinar today, and we hope that it was productive and beneficial to you all. Thank you, speaker, once again. And if you are interested in joining our future sessions and upcoming courses, you all can contact us and keep an eye on all these social media platforms that you can see on the screen: our LinkedIn, WhatsApp, Facebook, so that you all can be informed about the upcoming courses, webinars, workshops, and anything related that we will be organizing. And if you have any queries, you all can directly contact us through our WhatsApp and email. So thank you again, everyone. We will see you at our next webinar.